This is lesson number 9. This is limits of a function. So for you guys who probably have not seen something like this before, the limit is just an operation. So let's just make sure we get that straight, okay? So remember that the limit as x goes to c being a certain number, is just an operation. So keep that in mind. So it's actually very simple, at least starts off very simple. The first thing, as you look at this graph, okay, let's just talk about what the value of y at x is equal to 1 is. All right, so that's what this is asking me. What is the value of y at x is equal to 1? You can very easily tell that at x is equal to 1, y is equal to 2, right? That's the y value there. Okay, so the limit almost works the same way, except for you have to look at it like this. The limit as x approaches 1, okay? That's how you say the limit as x approaches 1. Well, you have to look at this graph right here, and as you come from the left and from the right, what y value are you approaching? And the answer to that also, as you come from the left and from the right, all right, you're approaching this y value, which happens to be the same. Okay, so that's how that works, very simple. Okay, on the next part, so let's look at the next one. So same thing, on this one it's asking us what is the value of y at x is equal to 1, and you can tell that that's 3. Alright, now the limit as x approaches 1 of f of x, so we have to come from the left and from the right, and what y value am I approaching as I'm approaching from left and right? Well, that y value happens also to be the same as that 3 right there. Okay, now on the next example, this is where it gets a little bit different. Okay, so on this one, notice that I have a hole. Okay, so I have a hole right here. So f of 1, so notice that f of 1, the y value right there, there's a hole right there. So the y value does not exist. Okay, so there is no y value at that point. So, because there's a hole. So again, there's a hole there. So it does not exist. All right, now when we talk about the limit as x approaches 1, as I come from the left and from the right, what y value am I approaching? Now notice that I'm not saying what's the y value. So I can get really, really close, infinitely close from the left and infinitely close from the right. And what is the y value that I'm approaching? All right, well the y value happens to be 2. Okay, so as you approach from the left and from the right, you're approaching the y value 2. Okay, so notice that this is a little bit strange because you don't have a y value there, but you are approaching y value 2 here with the limit. Okay, so that's the weird part. You can have a limit if there's a hole. Okay, now let's go to the next one. Now, on the next one, this is a piecewise function. Right, notice that I have a hole here, but I have a little filled in dot, which means that f of 1 would be that value right there, would be -1. Okay, so I do have a y value for x is equal to 1. Now, for the limit, you have to look at it like this, all right? So as you approach 1, x is equal to 1, which is right here, right? Read this line. As you approach x is equal to 1 from the left and from the right, you're actually approaching two different values. From the left, you're actually approaching positive 3, and from the right, you're actually approaching the value -1. Okay, so because of that, because you're approaching two different values from the left and from the right, the limit as x goes to 1 does not exist. Alright, so again, I'm going to write that down here for you, so when you look at your notes, maybe you can remember that. So, as x approaches 1, it approaches two different values. And that is the reason why the limit does not exist. All right. So if you're approaching two different values, the limit does not exist. All right. Next one. Now the limit as x goes. Well, let's do this one first. The y value at x. The y value at x is equal to -2 would be 2, all right? Well, actually, it does not exist because there's a hole there. All right, so notice that it does not exist because there's a hole. But the limit as x approaches negative 2, all right, again, remember, you're going to go from the left and from the right. What is the y value that I'm approaching? All right, well, the y value that I'm approaching is 2. So again, this is another one of the weird ones. I have a hole, but yet I have a limit, all right, and that can happen. All right, on this last example on this page, all right, f of negative 2. So the y value, what is the y value at x is equal to negative 2? Okay, well, on this one, even though it doesn't have a dot, maybe it should, okay, that right there would be negative 2. Right, but on the limit as x approaches negative 2, excuse me, I did not know there was going to be a bell there. All right, it's early in the morning. Okay, so as x approaches negative 2 from the left, I'm approaching the y value 2, and as I'm approaching from the right, I'm approaching the y value negative 2. All right, so on this one, just like before, because I'm approaching 2 different values, all right, from the left and from the right, this does not exist. So just like the one above, all right, I'm approaching a different value from the left, I'm approaching a different value from the right. So as I get closer and closer to those values, they're different. Okay, so the limit does not exist. All right, so let's go to the back now. If they give you something numeric, okay, so it says use the chart to find the limit of each of the following. Let me kind of show you the picture. I think the picture kind of helps. And just to kind of get some intuition. So that's what it looks like. Maybe you did know what that looks like because you know that if x is equal to 2, well, that's undefined, and that's why you have this asymptote, this vertical asymptote, right? So hopefully all the pre-cal classes you took last year did not go in vain here. But anyway, so you can tell there's something going on right there. Well, as x approaches 2, all right, so that's what we're doing here. As x approaches 2, and 2 would be like right here, if you will. 2 would be like right here. And they're not, I mean, you can tell that they're in between those two, right? So the easiest thing for you to do to fill out this table is just to press second and calculate, and then just go to the value and type in 1.9, for example. And that's going to give me negative 10. Now, without having to jump out of this menu, all right, you can do it again. You can just press, you can just actually type in 1.99 without having to get out of this menu, and that'll give you the next one. All right, so we got 100, and then we can just type in 1.999, and then that will give you negative 1,000. Okay. All right, so let me fill out this table real fast. So we got negative 10,000. So notice that what is happening as I get closer to 2 is I have a really big negative value. However, when I go to something that's a little bit more than 2, 0.0001, all right, so that is going to be 10,000. Not negative 10,000, but just 10,000. Okay, let me fill out the rest so you can see what this would look like. So this would be 1,000, this would be 100, this would be 10. All right, so look, sometimes, and you can actually very easily tell just by looking at the graph, right? What is the limit as x approaches 2? Well, as I come from the left, notice that I go down towards negative infinity. And as I come from the right, I go to positive infinity, all right? Now, you're not always going to have the graph to help you. But if you're looking at a table like this, okay, you should be able to tell what's going on. As you're coming from the left, you're going to negative infinity. And as you're coming from the right, you're going to positive infinity. Okay, now notice that you're going one way and you're approaching a different y value, if you will, even though they're infinity, you're approaching a different y value. So therefore, the limit does not exist on this one, all right? Because you're not approaching the same y value, okay? And again, you can tell just by looking at it. As I approach from the left, I'm going to negative infinity. As I approach to the right, I'm going to positive infinity. All right, so let's say that Okay, so if you don't have a calculator at home, that's fine. You can actually do this with your regular calculator if you had to. Okay, so make sure you get this done. We got 3.9, 3.99, 3.999, and then 3.9999, and then we got 4.0001, 4.001, 4.01, and then 4.1. Okay, so again, notice that this is the limit as x approaches 2. Okay, so I'm approaching, and 2 would be right here. Okay, so if you only had this graph, you can see you're not really looking at the graph at all. Okay, what value am I approaching from the left? 3.99999. And what value am I approaching from the right? Is 4.0001. And you can do a few more if you want to. If you plug in 2.00001, it gives you something that's really close to 4. So the limit on this one would be 4. Okay? So the limit as x approaches 2, the y value would be 4. So that one's actually not too bad. Alright, now every now and then, okay, so on this one, this is a little bit different. This one, there is no graph, there is no table. All it's asking you for is, what is the limit as x approaches 1? Alright? Now at first, they're actually very easy. All you have to do when you're dealing with a limit is you have to first, that's the first step you're always going to do, is you're going to plug in that 1 for x. So really all I need to do, again, plug in 1 for x. And I'm only plugging 1, right? Because that's what I'm approaching. So if I have f of 1, well, f of 1 would be 2 times 1 plus 1, which is 3. So the limit as x approaches 1 of f of x is equal to 3. Okay, so there's nothing really for you to do other than plug in that point. And by the way, you do have to kind of, if I'm gonna give you something like this, you have to write it all. You have to write the limit as x approaches 1 of f of x is equal to 3. Otherwise, it doesn't make sense. All right, so make sure you write that. Not on the table or the graphs, but something that looks like this. All right. Now number 4 is almost the same thing, except for this is a piecewise function. All right, so notice that. I don't know if I want to draw this or not. I don't really want to draw this, but you got 2x minus 4 if x is greater than 3. So to the right of the graph, you're going to have some kind of linear function, okay? And if x is less than 3, then to the left of it, you're going to have a different type of line, all right? Maybe at a different spot, and they are going to be at a different spot because notice that the y-intercept are different. Okay. So this is actually not too bad. All you have to do on this one is you also need to just plug it in. All right, so plug in 3 for x on both equations or functions. Okay, so plug in 3 for both. Now, if you plug in 3 for both, let me just go ahead and do that. All right, so we have 3 minus 4, and then we have 5 minus 3. All right, we got 6 minus 4, which is 2, and on this one we got 5 minus 3, which is 2. Okay, so therefore, the limit as x approaches 3 of f of x is equal to 2. Now here's one thing that it is different, okay? The thing that's different about this, well, how it could be different. Well, on this one, notice that if I'm not just plugging, I have to plug it into both x's, and they have to give me the same y value. If they don't give me the same y value, then the limit as x approaches 3 does not exist. Okay, so make sure you remember that. If I approach 2 different y values, the limit as x approaches, in this case, 3, would not exist. However, because I am approaching the same y value, then therefore the limit as x approaches 3 would be 2. Okay, finally on this last one, number 5, just look at it. This is already a fill-in table. I'm approaching, and you gotta know what you're approaching here. I'm approaching 0. Okay, so I approach 0 from the left and from the right. Notice that I have numbers that are similar, but this one's positive and this one's negative. Okay, so because I'm approaching a different y value, all right, specifically you can really tell here, one of them is positive, one of them is negative. Notice that this one's to the left of 0 and that one's to the right of 0, right? I'm talking about the x values. So this x value is to the left of 0, this x value is to the right of 0. As I'm approaching from both directions, I'm approaching on the right side a negative, but on the left side a positive. So therefore, on this one, the limit does not exist because I am approaching two different y values. Okay, make sure that you ask me questions when you see me, and I hope you watch this.